A couple topics from chapter 10. And one of the things you want to look at is suppose you have like a company that maybe like a job shop where they're going to make, say, just a short run of parts. So for example, maybe they're going to make 5 of one type of part, then they're going to make 3 of another type and 10 of another type. And so the question is, how do you do like a control chart for something like this? And so again, there's not enough data to do a full control chart. No statistical process control. By the time you begin some kind of analysis, you're on to another part. And so instead, what they recommend is you plot the deviation from, say, a nominal size for every part. And this is called you see at the bottom of your slide 2, it's called deviation from nominal, or DNOM control chart. And so what you do, so suppose like you're looking at, say, 2 different parts, and maybe the sample size is going to be 4, and the target dimension of you have a target dimension of part A and a target dimension of part B. So like, for example, for part A, you have like the mean of those parts, like would be over here. That would be like your M1 would be the sample mean number 1, and you subtract from that the nominal dimension, or the dimension you're shooting for, and then that will give you an X1. Then for your next sample, you calculate the X2 by taking your sample size minus your nominal dimension, and you get an X3 by taking your sample size minus your nominal, etc. And then you'll plot those, and then keep doing the same thing over and over again. So you have something, and then say you have another part. Let's say you have a part B. You're going to do the same thing, plot the mean of the 4, and you'll end up with something like this. So what you have here is you have like mean 1, mean 2, mean 3. So those are the measurements, say, for 3 different samples. And so the X1 will be your deviation from your target. So here, the target's 50. So your first sample is right on. So your X1 is going to be 0. It's right on target. Now your second mean that you sample mean is 51. So obviously that's going to be 1 off. And your third mean was 52. Obviously that's going to be 2 off. And so you're going to calculate the average of those differences from the mean and divide it by 3. So it's going to be the average difference. So for those 3 samples, your average difference from the mean was 1. And your range was going to be your largest deviation minus your smallest, or 2 minus 2. So the idea is, at every point, again, you're not going to compare it to the mean directly. You're going to find the difference between your sample and the mean and make a little table. It's pretty straightforward. Then find the average difference, and then find your total range. And so do the same thing for the next part. The next part, you can see 49 is going to be 1 below. 50 is going to be right on. 51 is 1 above. So we're going to have minus 1, 0, and 1. So your average is going to be right just at 0. But your variation is going to be the largest one, 51, minus the smallest one, which is 49. So it gives you 2. Then the next one, you can see the difference from the mean for the first samples is 2 below. Second one is 1 below. Third one is 2 above. Take the average of those. And the variation this time is the highest minus the lowest, which is 52 minus 48. And then next one, same deal. 49 is 1 below. 53 is 3 above. 51 is 1 above. The average of those three is going to be 1. Now, this time, of course, the variation, the highest minus the lowest is going to be 53 minus 49. So again, we do that, like say this was for part A that you're doing now. And like I said, let's say it's a job shop or something, but time you do like those 4, you're on to a different part. So once again, you do the same thing for the other part. The target mean for the other part was 25. Do the same deal. So here you have 24, which is 1 below, 27, which is 2 above, 26, which is 1 above. Find the average. And again, find the variation, the highest minus the lowest. And so you do that for all the parts that you're machining. You're always taking your target or your expected mean, take the difference between that and your sample mean, and go on the same, pretty much do the same deal. And so do that for however many samples you have. Then what you want to do, you want to take the average of those averages. So if you look, you probably can't see it up here too much on the screen, but on slide 17 in your handout, you're going to average up all of those means. So you're going to get a mean of the means. In this case, it's 0.17. And then also you're going to have the average variation, which is your R. And now you're going to plot like all of your samples. You're going to plot like your average X bar and your average R bar. But you're going to use this average of the averages here to set up your upper and lower control limit. So again, this is just a plot of your X bars all the way through your 10 samples. And just plot those. And plot your R, which is your variation. And now the question is, again, how do you calculate the upper control limit and lower control limit? We're going to use this. This is something you did earlier. This is on page 2 of your equation sheet control charts. It had these equations. We had done these previously. We have like the average of the average, and you have like an R bar, and then you use the pages from Montgomery. I think it gave you handouts of those. If you don't still have them, I can give you more to find the D2 on these. And that'll give you the upper control limit and the lower control limit for your chart. So this would be for the X bar chart. And same thing, let's see, yeah, so this time, so just putting the numbers in, we get the upper control limit of 2.93, the lower of negative 2.59. Again, there's going to be a difference because we're adding 17 at the top in front of all those. And then the center line is going to be a 0.17. Actually, our values came well within these, so they're not even, so our upper and lower control limits are way off the chart, so we don't even need to consider them because it looks like our process is well in control. Just the center line is shown here. That dotted line is the center line, but our lower control limit, upper control limit are way out there. So at least on this one, looks like our chart looks pretty good. And same thing for the R chart. You can calculate the upper control limit, lower control limit, finding that D3 and D4 again from Montgomery from those handouts I gave you. And once again, the center line is going to be that overall R bar. And when you put those, calculate those numbers, you get like a 0 up to 6.95, where the center line's at 2.7. Once again, this is well within our upper and lower control limits. And I've just shown the center line there. And so when we're doing these, we have several assumptions. We're assuming the standard deviation is the same for all the parts. And we have a constant sample size N for all the parts. It could be 3 or 4, whatever. And then we know what the nominal or desired target is. So that's the basic idea of the short runs. And in a few minutes here, I'll give you the a handout here to do some problems. Let me do, again, this is pretty straightforward. Let me do just one other one. So for a multi-stream process, this is the case where maybe we have maybe a machine that's making 4 parts at the same time. It's probably it's actually the same part, but it has like 4 heads or 6 heads or something like that. And so you're making the same part, and you're kind of checking how each stream is doing. So for example, you maybe have like say something like this. So if we have like 7 streams, these could all be coming from the same machine, but just different streams. You maybe have different tools making each of these, or in some cases, it could be just from 7 different machines. They're all making the same part. And so you want to monitor the process, see how things are working out. So at each time step, you take so many samples from each stream. Like it says here, find the N samples from each stream and find the average of each stream. And on the control chart, you only plot the highest and the lowest of the averages of these for each sample. And on the range chart, you only plot the largest range. So it's going to be, say, something like this. So let's say you have this and you have these 7 streams, and you've taken a sample size of 4. And so what we see here, again, we have the 7 streams. And so when we're taking our first sample, we're going to have 4 from stream 1, and we're taking the average of those. We have like 19.988. We're taking 4 from stream 2, and we have 21.931. We're taking 4 from stream 3, and the average of those is 23.257, et cetera, et cetera. So, and we're doing that, maybe every half an hour. So number 1 on the left column here, that's maybe the first time we're taking a sample, and we get those. Then we focus on, say, that first sample that we take, and we have these numbers. We're looking for like maybe the highest, the lowest, like say in this case here, notice that 4 was the highest. It had a 27.324, and stream 5 had the lowest, around 19.7. So what we're going to do is plot that highest and lowest value. And so we put that here. Again, the highest was at 4, the lowest was at 5. Then do the same thing at the next time we take a sample. Again, we have these averages from all the different streams. And now this time it looks like the highest is stream 1 at 25.8. And looks like the lowest is stream 7 at 20.051. So we'll plot that highest one, 25.8, and the lowest 20.05. So plot those here. Then go to the next line, find the highest and the lowest. This time it looks like the highest is at stream 6 at 26.8. And the lowest looks like stream 3 at 17.758. let's see. Was I looking at that right? Let me just double check. Yes, stream 3. Oh yeah, I missed stream stream 4 was the highest, 28.017. Stream 3 was the lowest at 17.758. And that's what's plotted here, the highest and the lowest again. And so you mainly keep doing that for every time you take a sample, could be every half hour, every 15 minutes. You're sampling you're taking 4 parts from each stream. Each of these numbers represents the average of those 4. So just go on and plot those. Just keep plotting them. And so the process needs attention if a point plots outside the control limits. Then again, just like before, it's considered out of control if it does. If one of the streams, at the other time when there might be a problem is if one of the streams gives the largest value several times in a row, or one of the streams gives the smallest value several times in a row. So we have to keep track of that. And so these are kind of the guidelines that if it ends up, let's say if you have only 3 streams, then you don't have to really worry about anything until one of the streams has 7 times in a row where it's either the highest or the lowest, not mixed. It's either highest or lowest. If you have 4 streams, then it goes down to 6. On the other hand, again, looking on your handout, and it might be hard to see at the bottom here, but on slide 79, it says if you have between 7 and 10 streams, if any of those, let's say 7 streams is high 4 times in a row or low 4 times in a row, then it needs attention. That could indicate there's something wrong. And again, now, when we're given the ranges, then we plot the ranges at every sample point. So the R chart for the multi-stream will look very similar to a regular R chart. And so like in this case here, again, it hasn't given us the range within each sample. So we in this particular example, we wouldn't have that. And just like before, we can plot the upper and lower control limit based on page 7 of your equation sheet control charts. For the X bar has this, where once again, the X double bar is the average of the averages. The R bar is the average of all the ranges. And the same if we have a R chart, it's calculated this way. Again, these constants are from the appendix of Montgomery, which you have those handouts for. And so again, that's for the multi-stream process. So I'll give you some handouts here. Recommend you do this on Excel, but let's say you have X1, X2, X3 like this. So maybe you have something like this. And again, this time we can see the average for TA was 100. So again, this one was 1 below. This one was right on. This one's 3 above. So then the average, like we had in this previous one here, is going to be like your X bar. And that'll be -1 in this case. -1 plus 0 plus 3 is 2 divided by 3. So 2/3 or 0.667. And then the range or variation R is going to be the highest minus the lowest, which is 4. So same thing over here. This is going to be what? 3 over, 2 under, 1 over. Once again, looks like that's 4, that'll be 2 divided by 3. Looks like that's also going to be 0.667. And the range is going to be 103 minus 98, which is 5. And so this is 0, 0, minus 1. So it's going to be what? Minus 0.333. Then highest minus lowest is 1. Then you're on to a different part when you get to this one here. Here, the nominal or target 65. So we've changed to a different part now. And so this is going to be, this is right on exactly 65. So it's 0. This one's 1 below. This one's 2 above. And so that, again, that's going to be average of 1 divided by 3, like this. And then the range looks like 67 minus 64, which is 3. And go on and do like that. Then when you're done with all those rows, do like we did in the example. This is back to this example here. Once you find all your X bars, find the average of those X bars, add them all up and divide by the total number, and that'll give you your X double bar, and add all the R values up and divide by the total, that'll give you your R bar. And then use those values to find your upper and lower control limits. The one thing to know, I think earlier in the video, I think there was an error. There should have been a negative sign on on the lower control limit. Yeah, so right here on this slide here, this should be a negative right here. This is the way it should look right here. In case your handout has a positive here, please change this to a negative right here. So the lower control limit should be X double bar negative here. Now the upper control limit should have a positive there, but the lower one should have, the lower control limit should be X double bar minus that fraction.